Oh, chemistry honors. He's pretty fast. Yeah. 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 So I'm equal with my only AP this year. Yeah. And I was gonna take chemistry honors next year. And I was like, I don't know. It's like, I don't need it. And yeah. Why are you up so far? I thought of this. My are so easy. I'm so sad I didn't do that. Summer. I shouldn't be like I did. Summer last year. Are we looking? I finished it, but it was like chunks, so it was had like a that's the way to go. I get so much done, but I also get so behind. Yeah, really. I feel like you should just get back to you to have like something and do it.
Okay, page 21. Again, we're still a day ahead. We're going to okay. We're going to just do this page and the next page. It's very much the same thing. I think the only difference is that we have to maybe read the table a little differently. Sometimes if we're not given the z-score, now we know how to use the z-score table. If you're given the z-value, you can use it to figure out the percentage. But today we have to go the other direction where you're given the percentage, you got to find the percentage, and from there work backwards to figure out the z-score and then solve for x that way. So still using the same formula, which is maybe having to potentially work backwards in our pattern. But let's go ahead and just go through a few of these and see if we can recall what we did last week, as well as to make that slight adjustment. Okay, so number one. So x is going to be a specific value. X bar is mean, and sigma under lowercase sigma is standard deviation. So number one, Jack took a standardized achievement test with a mean of 125. So we say we know X bar is 125. Standard deviation of 15, sigma. And the score was 148. So we know that's our X value. Okay, what's the percentile rank for the score on this test? So percentile rank just means a test score as well or better than the percentage of students taking the test, which means that whatever the z-score table gives you, that's percentage rank. You don't have to make any adjustment with that. So let's go ahead and do that. Here's a z-score formula. Okay, use your calculator. Okay, 148 minus 125 over 15. That's a positive z-score. So we look for 1.53. So 1.53 here. We look for 1.5 first, and once you find 1.5, you can go over, move over the few columns over to get that 0.03 added. So it's asking for percentile, so we got to convert that decimal to percentage, 0.937, which is 93.7 percentile. Okay, so now imagine having to work backwards here. Now let's say Jill scored at the 67th percentile, right? Just like how we were able to find 93.7 here, let's find 63.7. And then from there, we can kind of work backwards to the z-score. So 67th percentile, we'll try to find best we can where that 67 could be. So look for 0.67. Okay. If it doesn't land exactly on it, then you're just going to find two decimals that are closest to it. Okay. And pick the one that is closer to, but here it ends up giving us exactly that value we're looking for, 67%, which is a z-score of what? 0.44. Okay, so you know that you're working backwards here, 67th percentile. Gives us a z-score of 0.44. And then we can work backwards to figure out what her score is. Because now we know the z-score, we know the mean, we know the standard deviation. We're just having to work backwards, solve for it, I guess. Okay, so 0.44 is equal to x minus x bar over 15. Hey, if it helps, you may want to put that over 1 so you can see that if I just cross multiply, I can solve for x. Okay, get that decimal value. I think it's 6.6. Add the 125 to both sides. Okay, so this is what's new for today, where we know how to go from z to a percentage or decimal, but then working backwards, we may have to use a table, get that decimal, identify what the z-score is, and then continue moving backwards to figure out what is the x value that causes the score to be in the 67th percentile. Okay, so we're just going to work through these problems here. Okay, number 2, average number of absence for first grader is 15 with a standard deviation of 6. What's the probability of first grader having fewer than 6 absences? Okay, so we know that if it's fewer than, it's less than is good. That makes it an easier problem. Whatever decimal you get is fine, right? But if it's more than, then we have to make an adjustment, right? More than, what do we do with more than? We take the decimal we find and we do what with it? Good, we have to subtract from 1, yeah. So A is a little bit easier, and then we'll talk about B. Right, the value in question is x, is 6. Z-score. Okay, so negative 9 over 6 is negative 1.5. Negative z-score, so we go to our table. Negative 1.5. Think of negative 1.5 as negative 1.50, so it's going to be the first column there. But 0.0668. So we write it this way: the probability that a student has less than or equal to 6 absences is going to be 0.0668. Okay, part B, probability having more than 20 absences. Same mean, same standard deviation, different x value. Mhm. No, I'm sorry, 20 minus 15, not 25. We know it's going to be 1 minus the decimal value. So from that 0.83, we can figure what that decimal value is. Page 3. 0.83. Seven nine six seven. Okay, part C. If a student is absent more often than 30.85% of other first graders, how many days did she miss? Okay, so we can look for that 30.85% on our table there. So 0.3085, we'll look for 0.3085. Okay, 0.3085 looks like that's landing right at negative 0.5, z-score of negative 0.5. And solve for z. Right? We're using the same mean and same standard deviation for all these problems, A, B, and C. So that's -3 plus 15, which is 12. So we know 12 days. Is our answer. Okay. Same process for number 3. See if you can work through number 3 and we can compare our answers. Okay, continue through page 22, and I'll work through the problem as you guys are working through it as well. Okay, is everybody good with first page? Okay, does anybody still need it? Because I can leave it on this page for another few minutes. Page 22. Okay, number 5A is where we have to involve 1 minus the probability, right? We're looking for something greater, so. Another thing to keep in mind, if you ever see the word percentile or percentage, that means you're looking for a number out of 100. If it's asking for a probability, then it's a decimal that is less than 1. Right? So that's how you know whether to use, like for 4A, you're asking for percentile rank, so you're looking for a number out of 100. But for number 5A, it's asking for the probability, so you're going to leave it as that decimal, 0.0344. Let's see. Okay, for part B here, what's the probability that student will get a B? So a B is between 80 and 89. So because we typically round up, so anything that's between 79.5 and an 89.4 is considered a B. All right, 0.5 rounds up to the 80, and then 0.4 rounds down to the 89. So this is the maximum or the widest range it is for a B. Okay. So what we're going to do is we're going to find the z-score for each of these x values, and we'll find those two probabilities and then subtract them, and that will be our probability we're looking for. Right? So you got to find z-score twice, okay? And your mean and your standard deviation will stay the same. Just going through this process twice. It's like imagining doing two problems in one, basically what's happening here. Okay, questions so far? We'll go to the 10th, so let's make that negative 0.63 instead. That's fine. 6.2. Yeah, 0.63. Guys, for 7A, don't worry about the 1800. That 1800 is not going to be used until part B. So. Any questions, let me know. And go through any parts that that you want clarification on. Okay, I'll make a review for tomorrow. Quiz, check-in quiz will be on Wednesday. Let me come around and check pages 21 and 22. Whenever you guys are done with it, I'll come around in about a minute or two.